How does a dead rocket miss Earth, miss empty space, and find the moon instead? Why is a machine built by people now falling toward another world like it has its own final plan? The metal is still moving, the clock is still ticking, and Wednesday is getting closer. Somewhere above us, a silent piece of SpaceX hardware is on its last dive. If stories like this make your brain light up, subscribe now and stay close. This is for people who want the real mystery, not the loud myth. Because the deeper you look at this crash, the stranger it gets. Most people look at the moon and see something calm. It seems still, clean, and far away from the mess of Earth. But the moon is not calm at all when you study its face closely. It is a record of impact after impact, written in stone and dust. Every dark bowl, every bright ring, and every broken plane tells the same story. For millions of years, rocks from space have hit the lunar surface. That is why the moon is covered in craters instead of oceans, forests, or weather. Nothing softens the blows there, and almost nothing erases them. Now a new mark is expected to join that old record. Not from an asteroid, not from a comet, and not from a planned landing. This time the object is a dead upper stage from a SpaceX Falcon 9 rocket, and according to scientists, it is on course to smash into the moon on Wednesday. That sentence sounds like science fiction the first time you hear it. A rocket leaves Earth to help a mission, then later drifts through space and hits the moon by accident. It feels too neat, too dramatic, almost like a story written to grab attention. But the facts behind it are real, and they come with dates, numbers, and names. The object in question is the upper part of a Falcon 9 rocket. That is the section near the top that keeps firing after the lower booster separates. SpaceX used that Falcon 9 in January 2025 for a mission carrying 2 lunar landers and other science equipment. The mission moved on, but this piece of hardware never came back. People often think every major rocket part either lands safely or burns up. That is what many expect because modern launches are shown like clean, controlled events. What actually happens is more mixed, especially once a mission moves farther from Earth. Some hardware returns, some burns, and some is left to drift under the pull of gravity. That is the pattern scientists expected here too. A used rocket stage would usually be one more object far from the spotlight, moving quietly after its main job was done. Instead, astronomers studying public tracking data noticed something much stranger. This object was not just drifting in deep space, it was falling into a future meeting with the moon. NASA later backed that up through its Center for Near-Earth Object Studies, called CNEOS. That office often tracks asteroids and other objects moving through space near Earth. In this case, it also followed the path of the old rocket stage and agreed it was headed for impact. So this was not only internet guessing, major observers were watching it closely too. The expected impact time was about 2:35 in the morning Eastern Time on Wednesday. That is 6:35 in Greenwich Mean Time, the world clock many scientists use. The object was moving at around 2.43 kilometers per second. In ordinary terms, that is about 5,400 miles per hour, far too fast for a gentle landing. That speed matters more than most people realize. When people hear about a dead rocket, they often picture a floating shell moving slowly through the dark. But motion in space can stay huge for a very long time. By the time this stage reaches the moon, it will hit with enough force to carve a fresh crater. Bill Gray, an astronomer who tracks objects like this, said the impact should happen near the Einstein crater. That part of the moon matters because it is visible from Earth and lit by sunlight. In other words, this is not only a crash, it is a crash many instruments may be able to study. That turns an accident into a rare chance for science. The size of the object adds another layer to the story. Reports describe the upper stage as being about the size of a 5-story building. Its mass on Earth is at least 4,000 kilograms, or about 8,800 pounds. That is not a tiny shard of junk. It is a large metal body hitting a world with no air to slow it down. Gray predicted the impact could make a crater more than 17 meters wide. That is about 56 feet across, wide enough to feel very real once you picture it on the ground. And because the moon has almost no atmosphere, the rocket will not burn through thick air on the way in. It will slam into the surface almost as if nothing is there to protect it. Did you expect the moon's next crater to come from human hardware instead of a space rock? If that surprises you, hit like and tell me what feels strangest so far. And subscribe if you like your space stories real, direct, and a little unsettling. Here is the simple version of why scientists care so much. They expected the object to be one more piece of old mission hardware fading into the background. What they are actually getting is a known impact, at a known place, at a roughly known speed. That kind of event is rare, and rare events are gold for people who study impacts. Normally, a rock from space hits the moon with no warning. Researchers may see the new crater later, but they do not always know the object, the path, or the timing. This case is different because the incoming body is already being tracked. That means scientists can prepare telescopes and spacecraft ahead of time instead of guessing after the fact. Several groups plan to watch it. Large telescopes in the Americas were expected to look for a flash at the moment of impact. NASA's Lunar Reconnaissance Orbiter, which circles the moon, was expected to study the site later from above. South Korea's Danuri Lunar Orbiter was also part of the effort, along with help from citizen scientists. That wide effort tells you something important. This is not just a funny headline about space junk. It is a live science moment, one that could teach experts about craters, dust, impact energy, and even the shape of the rocket itself. A bad ending for the hardware may still become a useful beginning for new knowledge. Dr. Matt Bothwell from the University of Cambridge explained why the moment could be dramatic. He said the collision might throw up a huge plume of dust from the moon. That cloud could rise about 50 kilometers or more above the surface. That is around 31 miles, much higher than most people would guess from a strike like this. He also said as much as 1,000,000 kilograms of material could be blasted upward. That number is hard to feel unless you translate it into plain life. It means an enormous amount of lunar dirt and broken rock may leap into the airless sky for a short time. The moon may look still from Earth, but at impact, the ground could erupt like a sudden wound opening. Why does that matter beyond the shock of the image? Because fresh impacts can expose material from just below the surface. That helps scientists study layers that are usually hidden under old dust. In a strange way, a human mistake may scratch open a new page of the moon's history. And there is another question packed inside this event. What shape is the incoming object really in now? People may think a rocket stage is simple, like a can with engines at one end. But past impact evidence suggests the truth can be messier than the clean diagram. To see why, we need to go back to 2022. That year, another dead rocket body was expected to hit the moon. At first, many reports said that object was a SpaceX Falcon 9 upper stage from the DSCOVR mission. It sounded settled and the story spread fast. Then the case changed. Bill Gray later published a correction after better evidence came in. He said the object was not the Falcon 9 stage after all. The stronger match pointed instead to a Chinese booster from the 2014 Chang'e 5T1 mission. That twist matters for more than blame. It showed how hard it can be to identify old hardware once it drifts far from easy tracking. What experts first expected turned out not to fit the deeper data. What they actually found was that the wrong name had traveled faster than the best evidence. Gray explained the change using several clues. One came from John Giorgini at NASA's Jet Propulsion Laboratory, who pointed out that the Discover spacecraft itself never passed close to the moon. If the spacecraft did not make that kind of lunar flyby, the stage linked to it likely did not either. That was an early sign that the original SpaceX guess had a serious problem. Gray then traced the mystery object's orbit backward. When he did, the path showed a lunar flyby in late October 2014. It also lined up with the time and ground track of the Chang'e 5T1 launch. That backward match looked far stronger than the earlier idea tied to SpaceX. Another clue came from a small rideshare satellite called the Manfred Memorial Moon Mission. It flew with the Chinese launch, and its orbital data closely matched the mystery object's path. Students at the University of Arizona also studied the object's composition. Their work suggested the material looked more like Chinese booster hardware than a Falcon 9 upper stage. So the lesson from 2022 was sharp and humbling. People want simple stories, especially when a famous company name is involved. But deep space tracking is not always simple, and early labels can be wrong. That is why every new story about a rocket hitting the moon has to be handled with care. Do you remember hearing that older story and thinking SpaceX was definitely to blame? If you do, say when you first saw it in the comments, then hit like. And subscribe, because the truth in space is often less neat and much more interesting. The 2022 event became even more surprising after the impact. NASA's Lunar Reconnaissance Orbiter later found the site near Hertzsprung crater. Scientists expected one new crater from one incoming object. What they actually saw looked like a double crater, with two holes joined side by side. NASA described the impact feature as roughly 28 meters across at its longest part. That strange shape mattered because it did not match the most common picture of how a spent rocket should hit. Usually, experts think one end of a booster is much heavier, especially the engine end. A double crater hinted that the object may have had major mass at both ends. That is such a weird detail, and it matters here. The moon did not just record that an object hit it. The crater gave a clue about the object's balance, structure, and hidden weight. It was as if the surface itself corrected some of the assumptions made back on Earth. So when this SpaceX stage strikes, scientists will be watching for surprises again. They are not only asking where the crater will appear, they are asking whether the shape will fit current models. They are asking how much dust rises, how far debris spreads, and what the event reveals about the impact body. A single crash can answer several questions at once if the observation is good enough. This is where the story stops being only about one rocket. It starts becoming a story about what is happening in space right now. Every year, more missions launch. More hardware goes up. More objects are left moving after their first job is done. That means more paths to track, more uncertainty, and more chances for strange endings like this. The European Space Agency says there are around 54,000 objects in space larger than 10 centimeters. That is a little bigger than a softball, and big enough to matter in a collision. The agency also says humans have launched about 17,000 tons of objects into space since 1957. That is a huge amount of material, even before you count all the smaller fragments made later. Of course, most of that is not flying toward the moon. Most objects remain in or near Earth orbit, and many never come close to deep space. But the larger point is clear. The space around us is getting busier. And with more traffic comes more need for rules, better tracking, and better end-of-mission planning. Bothwell put it in plain words. He said more people should worry about space debris because we send more and more stuff into space each year. That warning is easy to ignore when everything seems distant and silent. But this moon impact makes the issue visible in a way many debris stories never do. There is no danger to Earth from this crash. NASA made that clear, and that part is important. The object is not coming back toward us, and it is not going to knock the moon out of place. But safe for Earth does not mean unimportant for the future of space activity. This event is a reminder that rockets do not vanish when the launch stream ends. A mission can be over for the public and still continue in hidden ways. Months later, a leftover stage can still be moving through the Earth-Moon system, still carrying force, still waiting for gravity to decide the last chapter. That is both fascinating and a little uncomfortable. Think about how people usually talk about space progress. We celebrate launch day, landing day, first contact, first image, first success. We do not spend as much time talking about the leftovers and their long afterlife. Yet sometimes the leftovers tell us just as much about the future as the triumphs do. Should every launch have a clear plan for where its biggest leftover parts will end up? Tell me yes or no in the comments. Hit like if this question matters more than people admit, and subscribe. Because the answer affects not only rockets, but the future traffic map of space itself. The moon is becoming busier again. Governments want to return people there. Private companies want to send cargo, tools, and machines there. That means the area around the moon is slowly changing from a rare destination into an active zone. When a place gets more active, mistakes matter more. A loose object in an empty field feels different from a loose object near roads, homes, and work sites. The moon is not crowded yet, but the direction is clear. More missions mean more need to treat lunar space as something that must be managed, not just used. That makes this crash feel like a warning from the early days of a new era. Right now, one dead stage may strike a remote part of the surface and mostly create a science opportunity. In a busier future, similar events could raise bigger concerns about safety, contamination, and interference with planned missions. Today's strange story may become tomorrow's policy argument. It also changes how we think about responsibility. On Earth, if a machine is left rolling toward a building, people want to know who planned badly. In space, the distances are larger and the times are longer, so responsibility can feel blurry. But the basic idea does not disappear just because the stage is above our atmosphere. That is why tracking old hardware is not boring background work. It is one of the quiet jobs that makes future exploration safer. Independent astronomers using public data helped flag this moon impact path. Agencies and spacecraft then joined the watch, showing how much science now depends on shared awareness. There is something hopeful in that teamwork. A NASA orbiter, a South Korean probe, large ground telescopes, and citizen scientists may all contribute pieces of the same puzzle. The object being studied is only a dead rocket stage, but the effort around it shows what human curiosity can do when many eyes focus on one event. At the same time, the need for so many watchers shows the scale of the challenge. We are putting more material into places that are hard to monitor perfectly. The farther we reach, the more careful we have to be with the hardware that does not come home. Exploration is not only about going farther, it is also about finishing well. This is where the story becomes personal, even if you never care about rockets. Modern life quietly depends on space systems all the time. Weather forecasts, map tools, ship tracking, farming data, internet links, and emergency signals all lean on objects above Earth. A messy space environment can ripple back into daily life in ways many people never notice. The moon crash does not threaten those systems directly, but it shows the same habit at work. We are very good at reaching space and not always equally good at cleaning up after ourselves there. That habit matters more every year because the number of missions keeps growing. There is also a deeper feeling many people have when they hear this story. We want space to feel pure, grand, and untouched by the careless side of human behavior. We want rockets to stand only for progress, courage, and discovery. Then a dead stage heads for the moon, and suddenly the picture becomes less noble and more honest. That honesty is useful. It does not cancel the wonder of spaceflight. It just reminds us that progress without cleanup leaves marks. Even on a world that has been taking blows for billions of years, our marks are now starting to count too. And still, there is something almost beautiful about the science hidden inside the accident. Because the impact may expose fresh subsurface material, it can teach us about the moon in ways routine observation cannot. A mistake may open a brief window into a layer normally covered by old dust. That is one reason researchers are watching so closely, instead of only shaking their heads. The incoming stage may also help test impact models. Scientists can compare what they predicted with the brightness of the flash, the spread of the dust, and the final crater shape. If the real event matches the models, that builds confidence. If it does not, then the moon has once again found a way to surprise us. Have you ever thought of a crater as a message instead of just a hole? If that idea hits you, write the word message in the comments and tap like. Then subscribe because some of the best space stories are really the moon talking back to us through damage. There is a reason people will remember this story. It turns the moon from a distant symbol into a real place where our choices still arrive. A machine launched in January 2025 may spend many months moving through darkness, then end by changing the surface of another world on a Wednesday. That time delay makes the whole event feel eerie. On Earth, many actions end quickly. You drop something and the result follows at once. In space, a decision can keep traveling long after the people involved stop thinking about it. A discarded stage carries the past forward, sometimes for years, until gravity finally closes the loop. That long delay should make us think harder. It means a mission is not fully done just because the payload was delivered. The hardware left behind may still have a future path and a future effect. Ignoring that path is easy in the short term, but space has a way of saving the bill for later. And the bill is not always money. Sometimes it is confusion, like the misidentified 2022 object. Sometimes it is risk, like debris in crowded orbital regions. And sometimes it is a literal crater on the moon, made by a machine that no one meant to send there. That is what makes this story feel bigger than one event. The more you look at it, the more it becomes a test of maturity. Can human spaceflight keep growing without dragging old habits upward with it? Can we build launch systems, business plans, and lunar missions while also planning the full life and death of the hardware involved? That is the real challenge hiding under the excitement, because if the answer is no, the problem only grows. More missions will mean more leftovers. More leftovers will mean more tracking headaches, more unexpected paths, and more debate about responsibility when things go wrong. The age of frequent space travel will demand a level of cleanup thinking that the early space age often ignored. This is why the event feels important even though it does not threaten us directly. The moon is acting like a giant witness. It records impacts without emotion, without politics, and without forgetting. When one of our own machines hits it, the surface becomes a permanent note about how we handled our technology. And what a note this may be. A 5-story object, at least 4,000 kilograms of mass, around 5,400 miles per hour at impact, near Einstein crater, under the watch of scientists waiting to see what the blast reveals. That image pulls together almost everything people love and fear about space. There is scale, speed, mystery, and hard science. There is human ambition, but also human mess. And there is the strange fact that our machines can outlive the story we told about them on launch day. The more dramatic question, though, is not what happens at impact. The more important one is what happens after we learn from it. Do agencies, companies, and future mission planners treat this as a weird one-day headline and move on? Or do they see it as one of those small warnings that matter more with time? History is full of moments like that. A strange event happens, people talk about it, and then years later everyone realizes it was pointing to a larger problem. This moonstrike could be one of those moments for deep space debris. Not because it is the biggest danger, but because it is visible, memorable, and hard to shrug off. The moon helps with that too. If this same stage burned up quietly somewhere unseen, most people would never hear about it. But the moon sits above us in plain sight. When a human-made object is expected to hit it, the story feels personal in a way deep space usually does not. It reaches down into ordinary imagination. Suddenly, space junk is not an abstract term anymore. It is a 5-story body falling toward a world children can point to from a backyard. That gap between the familiar moon and the strange cause of the impact is what makes people stop and listen. And once they do, they begin to see the future of space in a different light. Maybe that is the strongest lesson of all. Space is no longer only the place of rare, heroic missions. It is becoming a real environment, used by many players, filled with equipment, rules, mistakes, and consequences. The romance is still there, but it now sits beside logistics, responsibility, and cleanup. That may sound less magical, but in a way it is more honest and more mature. A species that wants to live and work beyond Earth cannot act like every launch is only a glorious beginning. It also has to care about endings, and sometimes a good ending simply means making sure a dead machine does not become someone else's problem. So yes, the headline is simple. A SpaceX rocket stage is expected to crash into the moon on Wednesday. But inside that one line is a bigger story about gravity, debris, error, science, and the future rules of exploration. That is why this event deserves more than a quick reaction and a shrug. There is also the question of what observers may actually see when the moment comes. Some impacts on the moon are hidden from view or happen in poor light. This one is expected near a sunlit region, which gives scientists a better chance to catch the event. Even so, nobody can promise a perfect view because the moon still keeps some secrets. A bright flash may appear for only a brief moment. Then the dust cloud, if it rises high enough, could spread and fade in the harsh light. That is why timing matters so much, down to minutes and seconds, not just the day. Miss the instant, and the most dramatic part may already be gone. The moon's lack of air is one reason the impact is so useful to study. On Earth, air pushes back, slows falling objects, and changes the shape of explosions. On the moon, there is almost nothing to soften the strike or carry the blast as wind. The crater and the dust pattern are shaped in a cleaner, harsher way. That clean violence helps scientists test their ideas. If they know the incoming speed and have a good guess about the object's mass, they can compare theory with the real scar left behind. Then spacecraft like NASA's Lunar Reconnaissance Orbiter can return later and inspect the crater from above. The moon becomes both target and notebook at the same time. There is also uncertainty built into every prediction. People may hear one exact impact time and think the event is known down to the heartbeat. But space tracking always comes with small error bars, which means tiny ranges of doubt around the best estimate. A small change in path can shift the final moment or the final point by more than most people expect. That is part of why independent astronomers matter so much here. They keep checking the numbers instead of trusting one early guess forever. Public tracking data lets skilled observers test paths, compare results, and challenge weak assumptions. This story is not only about a rocket stage. It is also about how open science works in real time. Citizen scientists matter too, and that detail deserves more attention. Not every useful set of eyes belongs to a giant agency with a huge budget. Sometimes a well-prepared amateur with the right telescope, the right weather, and the right timing can help confirm what happened. That turns the event into something shared, not locked away behind official doors. That point connects the crash to the future in a very direct way. If humans and machines spend more time on the moon, they will have to deal with dust in almost everything they do. Dust can coat surfaces, scratch parts, and cling in ways that make work harder. A sudden impact plume is dramatic, but it is also a lesson about a real lunar hazard. Another thing people often miss is how this event changes the idea of distance. The moon is almost 384,400 kilometers from Earth on average, or about 238,900 miles. That sounds impossibly far until a human-made object launched from our planet ends up striking it. Then the distance starts to feel less like an unreachable gap and more like a road we have already entered. And once a road exists, traffic follows. That is why stories like this are early signs of a larger future, not weird side notes to ignore. The path between Earth and the moon is becoming part of human activity, so the rules for what we send there, how we track it, and where it ends up will only grow more important. There is even a cultural side to this. For thousands of years, people looked at the moon and filled it with myths, gods, warnings, and dreams. Now we add another layer, one made of engines, fuel tanks, orbital math, and mission leftovers. The old mystery remains, but it now sits next to a very modern kind of responsibility. That mix of ancient wonder and modern mess is what gives this story its emotional pull. You can look up at the same moon your distant ancestors saw. But unlike them, you also live in an age when a machine from your own species can leave a new scar there by accident. The sky is not only above us anymore, it is part of what we are shaping. When people look back, they may remember the oddness first. Not a meteor, not a lander, a dead rocket. Then they may remember the numbers, the speed, the crater, the dust plume, and the chance to learn from the strike. And finally, maybe, they will remember the warning. We are clever enough to reach the moon again. The real question is whether we are careful enough to manage everything we leave in motion when we do. The answer will shape more than headlines. It will shape what kind of civilization we become as space stops being a dream and starts becoming a neighborhood. If you were making the rules, would you require every mission to prove the final fate of every major rocket part before launch? Subscribe and turn on notifications if you want more space stories that go deeper than the first headline. Then drop your answer in the comments, share this with someone who loves the moon, and thank you for watching. Thanks for being here, and stay curious.